So this marks the start of the beginning of the chapter on acids and bases. And whatever we've learned till now, whether it's balancing equations or ionic equations, radicals, all of this will be useful now in that chapter. It's going to make things much easier for you to understand. Now, definition of an acid. Now, you need to learn this definition, especially if you're doing IGCSE. So, an acid dissolves in water to produce H plus ions. So, any acid, if it is called an acid, is going to dissolve in water and is going to give you H plus ions. Remember when we were doing the splitting of the substances? So if when it splits, it gives you H plus, means that it is an acid. So see here. So here we had HCl. You see when HCl splits in aqueous, gives you H plus and Cl minus. Because it gives you that H plus means that it is an acid. So anything that gives H plus is an acid. So here we have a couple of examples of acids. You need to know all these acids and you need to know their formula. So the anions and the cations produced, so HCl, when it splits, is going to give you H plus, and the anion is Cl minus, right? And HNO3, it's going to split and give you H plus, and because NO3 is a radical, NO3 exists as NO3 minus ions. So you will have NO3 minus. H2SO4, it will give you H plus, but how many H plus do you have? You have 2 H plus. And SO4 forms SO4 2 minus radicals. Check the radical table. H2CO3, same thing, so H plus, but how many H plus? There's 2 H plus, and CO3 is CO3 2 minus from the radical table. So CO3 2 minus over here. And H3PO4 here, there is H plus, but how many H plus? Is 3 H plus and is going to form PO4 3 minus radicals if you check over here. Now, see that all these acids are producing H plus ions. Of course, it's producing different amounts of H plus ions, but they are all producing H plus ions, which means that they are all acids. Now, the strength of acid depends on its ability to give H plus ions. Now, there's two different types of acids in terms of strength. You have strong acids and you have weak acids. Now, a strong acid is going to be able to give H plus ions very readily, which means that if you have, let's say if in a beaker you have 4 molecules of strong acid, all these 4 molecules of strong acid is going to give you H plus. So each molecule is readily going to give you H plus. This is what we call a strong acid. It readily dissociates to give you H plus. All of these are strong acids given here, and all these, they readily give you H plus ions when you add water to it. So when they become aqueous, they give H plus easily. But a weak acid, on the other hand, let's say we have a beaker with 4 molecules of weak acid. When we add water to it, what will happen is that maybe only one will give you H plus. The rest will remain combined in the molecular state. So that one is going to dissociate, give you H plus. And then what will happen is that it will recombine and form back that molecule. Then it's again going to, now another one is going to dissociate, right? And again it's going to combine and form the molecule again. Then again, whenever it wants, another one is going to dissociate. So which means that at a time only a certain percentage. So here only 25% of the acid is dissociating to give you H plus ions. So we have 4, so 1/4 is dissociating to give you H plus. So all of them, they are not really generous in giving their H plus. They want to keep their H plus for themselves. This is what is a weak acid. Not very keen on giving H plus. So a strong acid dissociates completely to give H plus ions. Examples of strong acids. So I've given the formula, you write the names. So hydrochloric acid, sulfuric acid, phosphoric acid, nitric acid, these are strong acids, and these are usually called mineral acids. And this is what we usually use in the lab. And here you will see that complete dissociation means that all molecules will split into its ion, and it is shown using an irreversible arrow. You need to know the name of this arrow. This is called an irreversible arrow. And here it says hydrochloric acid dissociates to form H plus and Cl minus. So hydrochloric acid in the aqueous form, which means that when it dissolves in water, is going to split and give you H plus Cl minus ions. Right? It's only when it is dissolved in water, means that only when it is in the aqueous state. Now, do the same for nitric acid and for sulfuric acid. Include state symbols. Right? Now, weak acids, they dissociate partially in water to give H plus ions. This is what I was explaining in terms of dissociation. It dissociates only partially, which means that not all molecules will dissociate, only part of them will dissociate. And examples of weak acids are acids that we find at home, like vinegar, which is also called acetic acid, citric acid, which is found in fruits. You have ascorbic acid, which is vitamin C. So all these are weak acids, and vinegar is also called ethanoic acid. Both of these are names of vinegar. Now, when you look at here, so partial dissociation means that only some molecules will split into its ions, and this is shown using a reversible arrow. Be careful when you write a reversible arrow. This is not reversible arrow. This is wrong. You have to have half arrow on top and half arrow at the bottom. This is a reversible arrow, which means that the reaction goes on both sides, which means that the reaction will occur on this side, and then we'll get back on the other side here. So on this side, and then we'll get back on the other side. So they will occur, so it will go back and forth. This is what this arrow shows. It is a reversible arrow, means that reaction occurs on both sides. So ethanoic acids dissociate, make that correction, dissociate partially to form H plus and COOH minus ions. So CH3, COOH aqueous, which means that when we add this to water, will dissociate partially to give you H plus aqueous and CH3, COO minus aqueous ions. Right? Now, try to do the same thing with propanoic acid. Now, when you have these are called organic acids because they're usually found in organic substances. So these organic acids generally, let's say you have CH3COOH. What will happen is that last H here, that is going to dissociate. So same thing here, it will split here. Okay, so this is going to form the H plus, and this is going to remain in the molecule. Okay, so try to do this one.